In this video, we're looking to solve the rational inequality x minus 1 divided by x squared minus 4 is greater than or equal to 0. So in this problem, it's asking us where is our graph above the x-axis, right, greater than or equal to, or touching the x-axis. So where is it positive or 0, meaning where is it above or touching the x-axis. So we know that our graph is going to touch the x-axis at x-intercepts, and there's only one of those that happens here at 1. So this is going to be a point that is included in our solution set. So this will be included in the solution set. So we can see that our graph is above the x-axis at this portion here. And we know that we said that 1 is going to be included. So when we include it, we use brackets. So we're going to have a bracket here. And it's going to be all of the x values to the left of 1 up to this vertical asymptote here. So we know that vertical asymptotes, we are not allowed to touch or cross vertical asymptotes. So we never actually reach the x value of -2. So we get as close to it as we possibly can, but we never actually reach it, which means we will have parentheses there. So this is the first interval. This is the first interval where our graph is positive. We can see that it has all positive y values. So what is that in our solution form? So as in interval notation, it's going to be -2 up to 1. -2 is not included because of the vertical asymptote, and then 1 is included because it's an x-intercept, and we're looking for where it's greater than or equal to 0. So at 1, it equals 0. And then we can see from 1 to 2, our graph is below the x-axis. But then at 2, we have this vertical asymptote, and just to the right of it, we can see that our graph is getting really, really close to that vertical asymptote and moving up to a positive infinity value in the y. So it is positive to the right of this, but again, we can't include our vertical asymptotes. We use a parentheses there. And then it's actually going to stay positive forever because we have this horizontal asymptote that this is getting closer and closer and closer to. So it gets close to 0 but never actually quite reaches it. So it's everything to the right of our vertical asymptote there. Which goes from 2 all the way to infinity. So in interval notation, that would be from 2 to infinity. So those are the two intervals that are part of our solution set. In set notation, it would be the set of all x such that -2 is less than x, but is less than or equal to 1. So again, we use less than because it's the parentheses here from this vertical asymptote, and it's less than or equal to because of the brackets, and it hits the x-axis there at 1. So it's this, or x is greater than 2. And that's our solution to this rational inequality.